Hello, folks. Welcome, welcome, welcome. This is a little tutorial on just energy. Excuse me. First of all, energy is really, when we talk about energy, it's the ability to do work. Usually it has to have force through a motion. Okay, so it either has to be able to do force through a motion or it has to be able to have the potential to do that. Okay, so as you can see, oh, sorry, over here and again, I just picked that off the web, but I really could have had anything to do that. Now we're going to use an analogy. Imagine, if you can, think of it like, if you see this, it's kind of like a vault in a bank. We can look at energy sort of as like being something that you would, it's analogous to money. We can put money in a banking account. We can put it in a checking account. We could put it in a safety deposit account. It can take different forms, if you will, but it still can get stuff done. We can pull it out of an ATM, right? And out of an ATM, it'll come out as cash. But to do that, we need an ATM card. We could also use money in the form of a credit card. If we go traveling, we can also see that it can be in all kinds of different currencies. But in the end, right, the money has an effect in that it's going to hopefully get us some bling, right? Well, energy is analogous to money. It can take different forms, or be in different accounts. There's thermal energy, there's electrical energy, there's chemical potential energy. This one is talking about the bank account of thermal energy, which means thermal has something to do with heat. Now, typically when we're talking about heat, so we're going to talk about energy as heat flow. Thermal energy, the symbol will be Q. It's about heat flow. It's about this work going from something with a higher temperature to a lower temperature. And it's really important to understand that heat and temperature are not the same thing. So energy of the system, as it's flowing from one place to another, is going to have the symbol Q. Either Q is flowing out of something or Q is flowing into something. If I put an ice cube on a table, guess what happens? The energy from the surroundings flows into the ice cube, and the ice cube eventually starts to melt. Okay, so now this depends on a couple of different things. Obviously, the energy flow is going to have something to do with the change in temperature, or the temperature of which we'll see happen. It's going to have to do with something called specific heat and of course, change in temperature. Now, of course, here's me in a bathtub, and here's a tiny drop of water. Now, what does this have to do with anything? Well, with heat, imagine that drop of water having the same temperature, like 90 degrees Celsius, which is almost boiling. If I sit in a bathtub that hot, it's going to be way too hot. It could scald me and burn me. A little drop of water won't do as much damage. Same temperature though. And same compound. What's the difference? The mass is different. There's less stuff in one, more stuff in the other. That contributes to the energy flow. Temperature change is a big deal also. If I sit in a bathtub, and I'm thinking Celsius because that's what I do. Room temperature is 25 degrees Celsius. 30 Celsius is warm. If it goes from 30 to 25 in a bathtub, that's a certain amount of heat that flows. But if I change from 90 to 30 or 90 degrees Celsius to 25, that's a lot more, right? So change in temperature has something to do with it as well. And the last part is specific heat of a substance. And specific heat of a substance is the nature of the substance. And typically think of it like insulators or conductors of heat. For instance, when we talk about heat calories, it turns out heat is measured in joules or calories. And if you have a capital C calorie, that's the same as 1,000 lowercase c calories. And 1 calorie of energy can get 1 gram of water to change 1 degree Celsius. That's the specific heat, the amount of energy needed to change 1 gram of something 1 degree Celsius. Now, there's a difference. If I have a frying pan, frying pans have an incredibly low specific heat. And again, that's the good thing, right? It doesn't take much energy to get 1 gram to heat up to 1 degree Celsius or change in 1 degree Celsius, which is great. If these pans had a high specific heat, guess what would happen? It would take forever to cook stuff on the stove. On the other hand, when we live in a house and it gets hot and cold outside, we don't want to get hot and cold inside. Bricks, excuse me, are insulators. Bricks have a high specific heat, which means it takes a lot of calories of energy to flow into a brick to get 1 gram to change 1 degree Celsius. Sometimes we want a high specific heat. Now, what we're going to do is we're going to look at a little demonstration where we can actually see this heat flow. That's what we're shooting for.